Let's look at how good industrial ventilation systems are designed and installed. At the beginning of the design process, important questions are answered. At the emission source, one question is, how fast must the air travel to capture or contain the emission source? The answer to this question tells us the hood capture velocity. Similarly, how much air must be moved through the hood to control the emissions? The answer to this question becomes the volume flow rate, or Q, in CFM required for effective control. Next, how fast must the air travel through the ductwork in order to prevent dust particles from settling out in the duct? This airspeed is called transport velocity. Is an air cleaner required? The answer to this question must be obtained from the local air pollution authority that will issue a permit. How large should the fan be? Fans are chosen to match the requirements of the exhaust ventilation system. The fan must move the correct volume of air against the resistance to airflow caused by friction and turbulence in the system. The designer will estimate the static pressure required. How high should the stack be, and where should it be located? The stack must be high enough or far enough away from intakes to avoid re-entrainment of the contaminants into the building air handling system. These questions are usually answered through careful study of the industrial process, worker activities, the air movement in the workplace, and by searching design references for appropriate standards and design information. For example, OSHA has included some design criteria in its ventilation regulations. We'll discuss more about this later. Now, let's look at a few good practices to follow when designing, building, and operating a local exhaust system. Be sure trained personnel are used, such as ventilation engineers or industrial hygienists. Remember to enclose the source as much as possible, or bring the hood as close as possible to the source. The hood must be compatible with the worker and work practices. If it interferes with the work, productivity will be lost, or the worker may alter the hood, making it less effective as an emission control. This receiving hood over an induction furnace was cut by employees because they could not see inside to check the melt. Adding a flange to a hood will normally increase its effectiveness by reducing airflow from areas behind the hood where no contaminant exists, and improving velocity distribution in front of the hood where contaminants are generated. Flanging can reduce airflow requirements by as much as 50%, resulting in lower capital and operating costs for the system. A duct should be of the proper diameter and constructed of appropriate material. For example, when ventilated air contains sulfuric acid, stainless steel duct is often used. Be sure to maintain an adequate transport velocity in the duct, or the duct may fill up with dust. An alternative is to provide clean-out openings at intervals throughout the ductwork. This, of course, increases maintenance requirements. Avoid 90-degree T's in the ductwork. Turbulence resulting from changes in air velocity and direction causes pressure losses in the system, which must be overcome by the fan. Branches should enter at gradual expansions, at angles of 45 degrees or less, to maintain duct velocities while minimizing turbulence. Avoid two branches entering directly opposite each other to reduce turbulence loss. Avoid sharp elbows, such as this mitered elbow. The magnitude of pressure losses caused by elbows depends on the radius of the elbow curvature compared to the duct diameter. Where space permits, elbows should have a centerline radius of 2 to 2.5 duct diameters. Replace ductwork when it wears out due to erosion and impact damage from airborne particles. Maintain all ductwork in good working order. During design, remember to check with your local air pollution control agency to obtain a permit. The agency can give you guidance for selecting an air cleaner. The major types of particulate air cleaners include fabric filter devices such as bag houses, electrostatic precipitators, and cyclone separators. Gases and vapors are often removed from the airstream by scrubbers. Remember to provide protection for those handling materials collected from the air cleaner. Most users install monitors on the air cleaner to warn when the air cleaner is not functioning properly. When choosing a fan, be sure to select one which will provide the necessary static pressure and volume flow rate. Remember, though, the volume flow rate is always determined by emission control requirements at the hood. The fan is to serve the hood's need, not vice versa. Fans are divided into two main classifications: centrifugal, in which the airflow is at right angles to the axis of rotation of the rotor, and axial, in which the airflow is parallel to the axis of rotation of the rotor. Centrifugal fans are mostly used in local exhaust systems. The two important types are the radial blade fan and the backward inclined blade fan. The radial blade fan is the workhorse of the dust control industry because it is self-cleaning, rugged, and simple. Unfortunately, it is inefficient and noisy. The backward inclined blade fan is quieter, more efficient, and less likely to overload the motor at high volume flow rates. Unfortunately, it tends to clog or abrade when the exhaust air is laden with particulate material. The axial fan is used to move large volumes of air against small static pressures. It is often used in dilution ventilation systems and is usually noisier than equivalent centrifugal fans. Stacks should be tall enough to ensure that contaminants are adequately dispersed into the atmosphere. Stack exit velocities should be about 3,000 feet per minute. One rule of thumb is that the top of the stack should be at least 10 feet above the adjacent roof line or air intake, if either are within 50 feet of the stack. This will help avoid re-entrainment of exhausted contaminants into the building. Rain protection is often used. This illustration shows a slightly larger diameter duct mounted on the exhaust stack. Rain never falls exactly straight down, so when it hits the inside of the larger duct, it drifts down outside the stack. To avoid re-entrainment, don't use the slanted rain cap if the stack is close to the air intake for the building. Let's talk a little about troubleshooting existing systems. A major complaint is a lack of sufficient airflow into the hood. Look for plugged or dented ducts, or crimped or damaged ducts, or slipping fan belts, or the fan turning in the wrong direction, or worn-out fan blades, or misadjusted gates and dampers in the system, or a clogged air cleaner. When constant plugging of ducts is the problem, check the transport velocity. Is it adequate to prevent settling? If employees complain about the hood or refuse to use it, check to see if the hood interferes with work, or perhaps the hood just doesn't do the job of providing good emission control. All ventilation systems require maintenance. A good maintenance program consists of, first, a written program; second, a good record-keeping system to store drawings, plans, specifications, modifications, operating instructions, monitoring and testing results, and so forth. Third, a good program provides for regular testing and inspection of the system. Checklists can help. One is provided in the handout materials included with this program. All good ventilation systems are built to recognized standards. Some standards are mandatory, such as those found in the OSHA regulations and fire and building codes. Others are consensus or suggested standards. The handout materials contain a list of appropriate codes and standards. We have already mentioned OSHA's permissible exposure limits. The PELs limit airborne concentrations of chemicals to which employees may be exposed and are found in 29 CFR 1910, Subpart Z of the OSHA regulations. OSHA's ventilation standard, 29 CFR 1910.94, also provides construction and operating guidelines for ventilation of open surface tanks, spray finishing operations, grinding, polishing, and buffing operations, and abrasive blasting. Other OSHA regulations provide ventilation requirements for welding, confined spaces, sawmills, and chemical storage facilities. If you would like more information about OSHA or about how to comply with OSHA ventilation regulations, contact your nearest OSHA area office. This program has presented a practical overview of industrial ventilation. The handout materials provided with this program summarize and expand on the presentation. Remember, ventilation is only one way of protecting workers from exposure to air contaminants. However, it is one of the most important engineering control techniques for improving or maintaining the quality of the air in the occupational work environment.